Hello, my name is Ralf Regler and I'm working at NXP in the RF reader part and helping customers on getting their solution done.
So my name is Renke Bienert. I'm supposed to be the expert for the BN5180. I've been involved in the business of electronic passports, EID, and also electronic payment.
As NXP is number one on the payment market, we got lots of feedback from customers and lots of requests from customers for new chips and for also new features that we could implement, and all this input has been taken seriously.
Normally what customers want to have, and even end users want to have, is smaller and smaller devices. So that means that also the antenna size have to decrease, which then contradicts with the requirement of having a certain operating volume. This is just a matter of physics as such. Driving too much power into the antenna has several effects. First of all, it increases the overall current consumption, sometimes exceeding certain limits in terms of power supply, in terms of heating up the device and so on. Secondly, it transfers too much energy into the field, and as soon as you exceed this limit, you will fail and you don't get a certification. But in worst case, you may even destroy some tags.
So you need to have the power at the maximum distance at around 4 centimeters, and you are not allowed to exceed the limits at 0 centimeters. So this is the challenge at EMVCO.
The solution for this actually is the so-called dynamic power control, which allows us to control the field strengths, to control the power transfer of the reader IC and of the antenna system dynamically. This is why it's called dynamic power control. What normally happens is you drive a certain energy into the antenna. This energy is normally the maximum possible to achieve the maximum operating distance. As soon as a card or a mobile phone comes closer into the field, this changes the antenna tuning, and as soon as this increase of the power level exceeds a certain limit, the BN5180 automatically switches back the power to a lower level. And actually the dynamic power control uses certain gears that are related to transmitter settings, which the user can define. And these gears are switched due to the field strength which is measured.
The process with DPC now is that you are just making your matching. You have to do a few steps, but this is not a problem with the software that we are delivering with our new products, where you can just easily make this correlation.
So the NFC Cockpit makes the antenna tuning and optimization procedure easier and avoids lots of mistakes, because everything can be done with the graphical user interface and all the values are stored inside the BN5180 and then can also be dumped from the BN5180 and shared in the final design.
It is a really nice to use graphical interface to allow changes, optimization, and to use the chip without changing any line of code.
You can just download and install, and then it basically supports many things dealing with the BN5180, and one among them is the BN5180 dynamic power control calibration, which is a step-by-step process. In fact, it's just a couple of mouse clicks and then each antenna is calibrated. This control, this dynamic control, allows us to be more flexible, to build smaller antennas, and to get a better read range and still meet all the requirements.
The DPC makes our life easier also in terms of timing, because in the past we have also for critical designs we have spent quite some time to make the optimization, and now with the DPC it takes us 20 minutes to half an hour and everything is done.